Hey guys, and welcome back. It's day 3 of the iReady packet. It's March 18th, and we're going to go through page 12 through 14 today. That's 12, 13, and 14. So 64 fits into 162 times. And if you multiply that, you're going to get 128. Oh, I'm going to run out of space. That's okay. We'll make more. We're going to subtract. I know this takes a long time, but practicing this division is a crucial skill. Bring another 0. 64 fits in evenly to 325 times. Multiply, you're going to have to carry, and you'll see that it's nice and evenly. So yes, it's a lot of work, and our final answer is negative. Yes, it's a lot of work, but it's worth it to figure out division. My long division with decimals is super important. Let's keep going. Some more division. It says, explain the steps that you use to solve problem number 11. Where's 11? Oh, here it is. Boy. Well, some things that you'll need to do is set up the division house. You'll need to put your numbers in the proper places. I would definitely include that in your answer. The next thing I would write is I had to move the decimal out of the way on the outside and then out of the way on the inside. And you know what? There's so many zeros and swoops and stuff. I'm going to rewrite this so that it makes more sense to me. There's 56 in here and 4 on the outside. That looks much nicer. And our decimal point is right here where we left it. Now I'm going to divide like I always do. 4 fits into 5 one time. Multiply, subtract, bring down. 4 goes into 16 evenly 4 times. Multiply, subtract. No remainder. You can always check your answer by multiplying 4 and 14. 14 times 4. Whoops. For that, I think you could probably use a calculator and that would be okay. 56. Remember, writing out your answers and writing sentences is like summarizing your understanding. It's like writing summaries on notes in class, like normal. And I reminded you on Friday last that no one's there to look over your shoulder and make sure that you're writing, but writing is good for your brain. It closes the loop of learning. Make sure you're writing quality sentences. All right, moving right along. It says, write each number as a repeating decimal. To change a fraction to a decimal, you need to divide the numbers. Divide the numbers. So we're going to set up our fraction house. 1 goes in, 9 goes out. 9 doesn't fit into 1, so we're going to put the decimal, which was always there, you just couldn't see it, and a 0. Decimal comes up. 9 goes into 10. Multiply, subtract, bring down. 9 goes into 10. And you'll see that there's instantly a pattern, that this is just repeating on and on and on. It's 0.1 repeating. And this little bar means repeating. And you can put however many ones you want to with the repeating bar over it. Let's try an improper fraction down here in number 6. Improper fraction, where the top dog still goes in the house. I know you'll be very tempted to switch it around because one's bigger than the other. But the top number still goes inside when you divide. So 16 fits into 13 2 times. Multiply, subtract, bring down. 6 goes into 10 one time. Multiply, subtract, bring down. 6 goes into 40 6 times. Multiply, subtract. Uh-oh, I see that pattern. I see it coming out. where now all I'm going to get is a bunch of 6s. So my final answer here is going to be negative, don't forget it, 2.16, and only the 6 is repeating on and on and on. So we're going to put our bar, our repeating bar, over just the 6. Try the rest. Feel free to pause the video right here and try the rest of those problems, writing numbers as repeating decimals. It says when, let's look at number 9. It says, when the denominator of a proper fraction is 99, what do you notice about the repeating digits in its decimal form? Aren't they just the numerator? I think you should experiment. Let's keep going. All right, I think we're on to our final page for the day, understanding proportional relationships. Proportional relationships were Chapter 5, so we're really accelerating through our book here. Chapter 5 and Chapter 6 were all about proportional relationships. Let's try to tackle these problems here. It says, Josie is making pizza dough. Complete the double number line by filling in the missing values. Then write an equation that models the relationship between total cups of flour and number of batches. Show your work. So as I'm looking at this, I want very quickly to know what the unit rate is. I want to know how many cups of flour it takes per batch, because that's going to help me write my equation. So I'm looking right here, and this is the unit rate. There's 3/4 of a cup of flour per batch. And I can write an equation with that, where n is the number of batches is equal to 3/4 of a cup of flour. Oh, I'm sorry, 3/4 of a cup of flour is the number of batches. So I'm going to switch my variable around here. That way we'll know how much flour we need per batch. So if you want to make 5 batches, you'll be able to multiply 5 times 3/4, and you'll get your number of cups of flour. That unit rate is very important. Try that next one and check your answer, and make sure that you're checking, but only after you try. Let's try another one. Explain how using a table is similar to using a double number line, and how is it different? So let's look back at our 2 examples here. This is a double number line, and this is a table. It's similar because they have 2 rows of data. 2 rows of data in the double number line, and 2 rows in the table. It's similar in that they both have the unit rate. The unit rate's right here for this one. You have to find out what it is by dividing this, right? Oh, it says Lily bought each of her friends a pair of socks that cost $5.50. Oh, it even says it just in the problem. Complete the table, then write an equation. So this is going to be your unit rate. It should be included in your equation. And finding that unit rate is the same as finding it in the table as it is in the double number line. So those are similar. How is it different? How is it different? I think just the orientation of the material is different. The way it looks is different. That might be a little bit confusing. You might have a preference over one than the other. Let's look at number 4. It says Mrs. Lopez types at a constant rate. The constant of proportionality for the relationship between the number of words she types and the number of minutes she types is 38. Write an equation to show this relationship. So let's look at this. All you nitro typers out there who really love nitro type, this is her words per minute. She types 38 words per minute. And we're going to write an equation using W and M to show how many words she can type in a given amount of minutes. So 38 words in a minute. If she types for 2 minutes, she'll put out 76 words. So 38 times minutes is words. That's how you write an equation. Of course, you might be used to it more like this, where it's 38, and then you could plug in any amount of M, 4 minutes, 5 minutes, 6 minutes, and it would output however many words she typed in that amount of time. Make sure you check your work. Check my work too. With the teacher key or the answer key, it's on my website. If you have any trouble at all, make sure you send me an email. Hope you're doing well. I miss you guys. See you soon.